Hi to all. Speed control techniques of three-phase induction motor. This is important topic for the electrical competitive exams. We know that S is equal to Ns minus N by Ns, where S is slip and Ns is synchronous speed and N is rotor speed. This rotor speed is controlled by controlling slip and synchronous speed. Why the speed of the motor is controlled? For power saving and for the smooth operation of the motor. Speed is controlled by controlling the slip. In the slip, we have three methods. One is voltage control technique, which is used for both squirrel cage and slip ring induction motors. And second one is rotor resistance method, which is used for slip ring induction motor. Third one is rotor EMF injection method, which is also used for the slip ring induction motor. And second way is speed is controlled by controlling the synchronous speed control. In this, first one is frequency control technique, which is used for both squirrel cage and slip ring induction motors. And the second one is pole changing technique, which is used for squirrel cage induction motor only, because in squirrel cage the rotor poles are automatically changes when changes happen in the number of poles of stator. But in slip ring induction motor we want to change poles physically. So pole changing technique is only used for squirrel cage induction motor. And third one is cascading of induction motor. In this, two motors are used. One must be slip ring induction motor and another is squirrel or slip ring induction motor. Now discuss about the voltage control technique, which is used for both squirrel cage and slip ring induction motor. We know that torque is directly proportional to the SV square by R2. In order to maintain the torque constant, when voltage is decreased, slip is increases, which implies speed is decreased. So speed is controlled by controlling the voltage. The formula is when torque is constant, SV square is equal to constant. Drawbacks of this voltage control technique. Induction motor draws high current yet reduced voltage. Due to stator heating problem, this method is not suitable for long duration speed control. So this is only used for the narrow range speed control technique. Next method is rotor resistance method in slip control technique, which is only used for the slip ring induction motor. We know that torque is directly proportional to the SV square by R2. In this method, an external resistance Re is injected into the rotor circuit. So the formula becomes torque is directly proportional to the SV square by R2 plus Re. When the torque is constant, if resistance Re is increases, slip increases, because resistance is directly proportional to the slip. If slip increases, speed is decreased. So by controlling the resistance, speed is controlled. The formula is S1 by R2 is equal to S2 by R2 plus Re. Drawbacks of this method are due to the increase in the resistance, the copper loss takes place. If the losses are increases, efficiency will decrease. This method is not economical for narrow range speed control. Next method is rotor EMF injection method in slip control technique, which is only used for the slip ring induction motor. When the injected EMF is in phase with the rotor EMF, the resultant EMF ER is equal to E plus EI, where E is the rotor EMF, ER is the resultant EMF, EI is the injected EMF. When the injected EMF is out of phase with the rotor EMF, then the resultant EMF ER is equal to E minus EI. In this way, by controlling the resultant EMF, the speed is controlled. The formula is when the torque is constant, to solve the problems S1 E square is equal to S2 ER square, where E is the rotor EMF, ER is the resultant EMF. Thank you for watching.